Okay, yes, we're live. Okay, so today's lesson is absolute value equations and inequalities, and as I've told you, I really like absolute value inequalities, and that goes with our standard here. This last line may include absolute value inequalities. So it's telling you straight up that on the keystones, you are very likely to see some absolute value inequalities. Okay, so first let's talk about what absolute value means. Absolute value of a number means its distance from 0 on the number line. So if it says that the absolute value is 8, we could have two different positions on the number line. We could say that x equals positive 8, because if we're at positive 8, we're 8 units away from 0. Or we could say that x equals negative 8, because negative 8 would also be 8 units away from 0. It's just in the other direction. So when we take the absolute value of a negative 8, it equals 8. So when we substitute negative 8 in for x up here, like I did right here, then we are saying that absolute value of any number is always positive, because distance is always a positive number. Okay, so when we have something like absolute value of x plus 2 equals 9, before we can decide about the positive and negative, we have to solve the equation so that all we're left with is the absolute value on the left. So we're going to solve for x, only x is inside an absolute value sign in this case. So I'm going to subtract 2 from both sides, and whoops, and I end up with absolute value of x equals 7. So now I can turn around and do what I did in the last problem. I can say that x equals 7 or x equals negative 7. So whether I put a 7 or a negative 7 inside that absolute value sign, the absolute value is going to be positive 7. Okay, same thing for the next one. I'm going to solve for absolute value of n by itself. So I'm going to add 5 to both sides. I end up with the absolute value of n being equal to 3. So I can say that n either equals 3 or n equals negative 3. Okay, I have a couple more that are not on your flip chart that we're going to do as well. I want to look at this one because this is a little bit different. X plus 3 equals 9. So just kind of include this at the bottom of your current slide. So if the absolute value of x plus 3 equals 9, we can't solve for x the way that it is, because the 3 is inside the absolute value sign, and we can't just take it out. So what we have to do is, as soon as we get to where it's only absolute value on one side, then we set it up the same way. So on the first equation, we wrote x equals 8, x equals negative 3. For this equation, we're going to write x plus 3 can equal 9, that's obvious, or the less obvious is that x plus 3 could equal negative 9. So whatever's inside that absolute value, if it's total, if the sum of x plus 3 is negative 9, when we take the absolute value of that, that will be 9. So then we have two equations to solve. We have the x plus 3 equals 9, so I'm going to solve that one first. So x could equal 6, or over here subtracting 3 from both sides gives me x equals negative 12. So x can be one of two values to make that equation true. So if we put a 6 in for x here, we'd have 6 plus 3, and that's 9, and the absolute value of 9 is 9. If we put in a negative 12 for x, we'd have negative 12 plus 3, which is negative 9, and the absolute value of negative 9 is 9. Okay, let's look at one that has some multiplication involved. Same slide. 2 times the absolute value of 4x equals 40. Okay, this one, our goal, just like before when we solved equations, we were solving for x. Now we're solving for the absolute value. We just need to get the absolute value alone on the side. What can I do to that side? Because right now I have something in the way. It's not just the absolute value sign. There's something else there. What could I do to get rid of that? Any ideas? Cheyenne? We could divide by 2. Good. So I'm going to divide both sides by 2. On my left side, I'm just left with absolute value of 4x. On my right side, I'm left with 20. Now I can do what I did in the other problems. Volunteer to tell me how I might set up the two equations without absolute value signs. Athena?
Without the no lines on the sides?
Yes, without the lines.
4x equals 20, or 4x equals negative 20.
Good. 4x, kind of running out of space over here, equals negative 20. So all we do is we take the absolute value sign away. The first equation, this one, is exactly like the original equation, except that we lose the absolute value sign. The second equation is exactly the same, except that we make whatever's on the right negative. Okay? So now we solve both of these. Dividing by 4 gives us x equals 5, or x equals negative 5. And we can check that in the original equation and see that that's true. If we put 5 in for this x, we have 4 times 5 is 20. Or wait a second, 2 times 4 times 5 is 20. The absolute value of 20 is 20, and 20 times 2 is 40. If we put negative 5 in, 4 times negative 5 is negative 20. The absolute value of negative 20 is positive 20, and positive 20 times 2 is 40. Okay, any questions about this before we do a couple more? Okay, go to the next slide. There's some more examples. Okay, these ones we need to solve. There's more to do, so it's like a multi-step absolute value equation. So I'm going to call on some people to tell me what to do first. Let's see, I'll take volunteers on this since it's a new thing. Any volunteers? Lacey? Good. Subtract 12 from both sides. So we're left with 3 times the absolute value of 2z plus 9. And that equals negative 2. Okay, volunteer to tell me what to do next. Rosa? Good. Divide by 3. So now we have absolute value of 2z plus 9 equals negative 2/3. Now I want you to think for a minute. We could write this as 2 different equations, but we have a little bit of a problem here. We have an absolute value over here on the left, and then we have a negative number over here on the right. Does anyone see a problem with that? Athena?
Absolute values are negative.
Right, absolute values cannot be negative. So we cannot take the absolute value of 2z. It doesn't matter what z is. Whether we get a positive value in there or whether we get a negative value in there, there is no way the absolute value of anything can equal a negative number, because absolute value is always positive. So at this point, we can stop doing this problem and we can say there's no solution because absolute value cannot be negative. Okay, let's look at the next problem. Let's see, we've had a little bit more experience, so I'm just going to call randomly now. Maddie, can you tell me what we might do first to begin to solve that one? Good. Add 5 to both sides. So we end up with 2x, absolute value of 2x minus 6 equals negative 2. What would we do next? Volunteer. Athena?
Once again, there'd be no solution.
We do nothing because once again, there's no solution. Well said. So absolute value of something cannot be negative, so we stop at that point and we say that there's no solution. Okay. Any questions before we move on to inequalities? Okay, let's move on then. Okay, when we are doing inequalities, I think they're fun to do. It says the absolute value of x has to be greater than 5. So obviously, if x is 5 or greater, we're good, right? Where else, what other range of numbers would work for this? Cole? Yeah, start at -5 and go the other way. Because all of those numbers that are less than 5, less than -5, are going to have an absolute value that's greater than 5, because we're going to take away the negative signs. So the way that we solve an absolute value equation is we write the two, I shouldn't say equation, these are inequalities. I always want to say equation, they're not equations. I want to write two inequalities. The first one is exactly like the absolute value inequality, except I get rid of the absolute value signs. So I just eliminate the absolute value signs, write it down. The second one, you have to change the sign because of the number line being like a mirror and being reflective, and then I make it less than -5. And this would be an or inequality because we have those ors going out to the side. And that's true every time we have a greater than absolute value inequality, we're going to use an or. If we have a less than, we're going to use an and. Okay, so let's take a look at the next one. We'll actually start by solving it rather than start by putting it on the number line. So I need to write two inequalities. Adam, what would my first inequality be?
X is less than or equal to 3.
Good, I just write x is less than or equal to 3. And Gretchen, what would my second inequality be?
X is
Flip the sign.
greater than
Uh-huh.
-3.
Good. So we flip the inequality sign, we make it negative. So graphing that, I have x is less than or equal to 3, x is greater than or equal to -3. This is an and inequality. So you could write the word and in there, or you could express it as -3 is less than or equal to x is less than or equal to 3. Okay, let's move on to some where we actually have to do a little bit of solving. Okay, we have the absolute value of n minus 1 is less than 2. It's already solved for the absolute value. We have only an absolute value sign on the left, so I'm going to go right to the step of writing two inequalities. Zane, what would my first inequality be?
N minus 1 is less than or equal to 2.
Just less than, no equals in there. Less than 2. Okay, good. And then because this is less than, this is going to be an and inequality. Rosa, what would my second inequality be?
N minus 1 is greater than -2.
Good. And minus 1 is greater than -2. And at this point, I could put them together in the whole sandwich kind of inequality. I don't have to. I can leave them separate and work with them separately, but I'm going to put mine together into a sandwich. I'm going to say -2 is less than n minus 1, and m minus 1 is less than 2. Okay, now I'm just going to solve this inequality how I normally would. So I'm going to add 1 to all three sides, and I get -1 is less than n, which is less than 3. Open circle on -1 and 3, and a line connecting them. Okay, next one. It's almost the same inequality, but I have a greater than sign instead of a less than sign. So my two inequalities are just going to be m minus 1 is greater than 2. And then am I going to use an and or an or? TJ? Or. And what would my new inequality be, Liz?
N minus 1 is less than
-2. Good. n minus 1 is less than -2. So this one I can't put together in a sandwich, so I'm going to solve each side. N is greater than 3, or n is less than -1. So I again have my endpoints on the same place, my -1 and my 3 have open circles, but my arrows go out to the sides like oars on a boat because we have an or inequality. Okay, one last slide. Some examples with multiplication. So again, it's already solved for the absolute value, so we don't have to do any solving to get the absolute value by itself. Jocelyn, what would my first inequality be? Okay, and am I going to use an and or an or? What's that? No? I'm going to use or. Can anyone tell me why I'm going to use an or and not an and? Sophia? Greater than. Anytime you have greater than, you're going to use an or. Anytime you have less than, you're going to use an and. So I'm going to have or. And my second inequality, Cheyenne, would be what?
A n is less than or equal to -24.
Good. Okay, so solving these inequalities, I have n is greater than or equal to 3, 4, n is less than or equal to -3. So on my graph, I use closed circles. And again, it looks like oars on a boat. Emma Lillybridge, next one. What's the first inequality that I would write?
5x is less than 20.
And am I going to use an and or an or?
An and.
And, good. Why?
Because it's less than.
Less than, good. Sam, what would be the second inequality that I would write?
5x is greater than
Okay, so then solving this, we're dividing both sides by 5. X is less than 4, and this one I did not put together in a sandwich. I'll do this one the other way. And x is greater than -4. So I could write this out as a sandwich. I'm going to do it down here. -4 is less than x is less than 4. Open circles. Sandwich includes all the points in between. Okay, any questions? Because absolute value inequalities are somewhat tricky, I'm not going to have you do the challenge assignment on this. I want to make sure you're solid with the regular ones, and then we'll add in some of those. So your assignment is just the basic assignment. Okay, let me stop this.